Hey everyone, today we're going to show you everything you need to know in order to use SOH CAH TOA trigonometry in your exams. Now this is part 1 out of 3 for this series, so in this part I'm going to explain in detail how to do it. I will also link in the bottom part 2 and 3, which have harder examples and exam style questions using trigonometry. I'll see you there. When do we actually use sine, cosine and tangent? One of the requirements is that we need a right angle triangle. Why do we want to even use this? Or when do you know when you have to use sine, cosine, and tan? Well, it's because when you want to figure out either side lengths or the angles in a right angle triangle. And how do we do that? Well, we need to use the sine, cosine, and tangent function on our calculator. Here we have a right angle triangle. And it's very important that you guys remember 3 things. In a right angle triangle, we always have a hypotenuse, an opposite, and an adjacent side. The hypotenuse is the one that you always need to label first. This is the one that is opposite of the right angle. This is always also the longest side in a right angle triangle. Now the opposite and the adjacent may change depending on what the other angle is that we're looking at. If we're looking here at the green angle that we've got, then that means that we're going to have the opposite side, which is the side opposite the angle, is O, and adjacent means next to, so that's the side that's next to the green angle. Now, it is very important that you guys get these ones right, because only then you can use sine, cosine, and tan correctly. Let's have a look here. If we now have the other angle in the same triangle, again, we need to start labeling our hypotenuse first, the side opposite the right angle. Then the opposite is the side that is opposite the angle that we're looking at, which is over here, and adjacent is next to the side, next to the angle. If you need extra support with your studying, join our free Discord community where you can ask questions, get help, and even request me directly for one-on-one tutoring. Inside the Discord, you'll also find a full resource hub with worksheets, study guides across different subjects, and I highly recommend checking out my website where I've put together full courses organized in order so you won't miss any of the topics. You'll find both links to the Discord and the full courses right below in the description. Alright, in order to use sine, cosine, and tangent, we need to remember 3 triangles. I recommend remembering SOH CAH TOA in order to remember these. These are not given to you in formula sheets, so you need to be able to come up with these from scratch by yourself. Now here S will stand for the sine, C will stand for cosine, and T will stand for tangent. O, H, and A are the hypotenuse, the opposite, and the adjacent, just like we spoke about just now. So what we're going to do is we're going to use these triangles to kind of remember our SOH CAH TOA and make these questions very easy. If you remember SO, then this is the order that we need to put them into our triangles. So we're going to have S, O, and H. And I want to emphasize that the letter that is in the middle is always the letter that's on top. So what about for CAH? For CAH, again, the A is in the top, so that is the one that is in the middle between C and H. And for TOA, the same thing, we have T, O, A. If you guys are able to replicate these triangles at any time from memory, then you're ready to use sine, cosine, and tangent to calculate any trigonometry question. So let's have a look how we actually use these triangles, because if you're able to replicate them, we can very quickly and very easily get to answers. We kind of separate our triangle into a fraction line, which separates the bottom and the top half. And we're also separating it by a vertical line, because that is the front and the end part of the SOH CAH TOA triangles. So if we now remember that the green line, the horizontal line, is a fraction line, and the vertical line means multiplication, we can now use that much easier to get the answers using these triangles. So let's, for example, go to SOH, which is the SO part. Now, what this means is that if we wanted to find one of these, the thing that we do first is we cover the one that we want by our thumb or any finger. So for example, let's say we wanted to find the opposite here. Let's cover that one. Then we have the opposite is given to us by S and H. But S stands for sine of the angle, and H is the hypotenuse. But because there is a vertical line, that means we multiply them together, and that is the answer once we've put this in the calculator. So let's do this one more time with a different example. Let's say in this example, we are using TOA, T-O-A, and we want to find the adjacent. Then we cover the adjacent with our finger, and now what is left here is O and T. So the one that we are wanting to find is equal to whatever is left. So we have O divided by T. Well, O is the opposite, and T stands for tan of the angle. So if we now put this into our calculator together with the numbers of the actual example, then we'll be able to move on and find the answers for our questions. Awesome. Let's have a look at a real example over here. Let's say we have 10 centimeters on the side, and we have 15 centimeters on the side, and we've been given that this angle over here is 20 degrees. So how can we now figure out the other side? Let's call this side X. The first thing that you guys should do is write down your SOH TOA triangles. So let me just quickly do that. SOH, CAH, and TOA. And we can put our triangles around it if we want to make it pretty. The reason why I'm doing this fast is because I want to show you guys that this is something you guys need to replicate quickly in order to do this in a test. So in this question, we're going to now label our hypotenuse first, which is the side opposite the right angle. Now we're looking at the angle 20 here. This is the angle that we're interested in using. So that means the side opposite that angle is O, and the side right next to it is A, the adjacent. Once we have these, we need to figure out which of these triangles we're going to have to use. And we definitely have to use something with an O because we want to find the side X, which is our opposite. Now, we can either use the hypotenuse or the adjacent here. It doesn't matter, but let's have a look. If we wanted to use the hypotenuse, then we have O and H. If we have O and H, let's have a look, and we want to find the solution here, then we have an O and an H in this triangle over here. So that means we can use sine here, the SOH triangle. Well, how did it work again? The side that we wanted to find out is O. So we're going to cover O, and what is left, we have S times H. So we can in one step write X is equal to S stands for sine, and sine always is the angle that we have, so 20 degrees, when we multiply it by H, so that is the hypotenuse 15. If we now want to put this in the calculator, we can just quickly switch over here. There we go. We're going to go to our normal menu, and all we're going to do is we're going to press the sine button here in the corner, 20, and then we multiply by 15. If you want to, you can happily put this into brackets. There we go. And we're going to get an answer of 13.7. Now, before you guys use any of the SOH TOA questions, you guys need to make sure your calculator is set to degrees. You can also find angles in radians, but more about that later. So let's have a look at our calculator and see how we can check this. We need to go to the setup, which is Shift menu, and now we can scroll down to angle. And we can see here in the example here, we are currently in radians. So in order to change that, we need to press F1 for degrees. Once we have that, we can go back to our question, press enter again, and now we will find out that the actual side length is not 13.7, but 5.1. So we find that x here is 5.1. It is very easily done to forget that you guys have to check if you're in degrees or in radians. So I recommend that before an exam, after you guys have to reset your calculator, the first thing you guys always do is write down your triangles and then put your calculator into degrees. Okay, next one. Let's have another example over here. Let's say we have an angle of 40 degrees here. This is 7 centimeters, and we want to find this side and this side. So again, pause the video if you need to, but let's get started. The first thing we are going to do is write down where our sides are. So for example, the hypotenuse is opposite the right angle. The opposite side of our 40-degree angle is x, and the adjacent is the one right next to it, which is 7 centimeters. Now we're going to check what we have and what we want. We definitely want x, which is O. Let's start with x. So we have the opposite involved, and we have the adjacent involved. So which of the triangles has an O and an A? Well, you guys can check. It is TOA. Once you guys have written down your triangle again, remember the one that we want to find, which is the opposite here. We're going to cover up with our thumb, and we're going to write our answer. So x is equal to t times a. T stands for tan. And of course the angle, it's always sine, cosine, and tan of the number of the angle, multiplied by the adjacent, which is 7. So let's go and grab our calculator and put that in. So we're going to have to go tan 40 times 7. There we go. And we get 5.8. So we now know that x is 5.87, so 5.9. That's the 1 decimal point, yeah? 1 decimal place. Okay, wonderful. So if we now have a look at this question, yeah, we can also find y. But if we want to find y here, some things change. Let me get the colors here off. There we go. Okay, so if we now wanted to find what y is, we need to start over and have a look which triangle we can now use. If we wanted to use again our adjacent and the hypotenuse, which we're looking for, we have an A and an H. So that would be CAH. It has an A and an H in it. So if we now figure out that we want to find the hypotenuse, we cover that up with our finger, and we have left A over C. So we can now write y is equal to A, which is the adjacent, 7 divided by C, and C stands for the cosine of the angle. Now, if we put this into the calculator again, you guys can just go and press the button for a fraction. And we're going to go 7 divided by cosine 40 degrees. Which gives us a value, let's put it over here at the bottom, which gives us 9.1. Again, 1 decimal place. Okay, we've now found all of the sides in this triangle. I've got one more example over here for you guys. Let's say this side here is 15 centimeters and this side on the other side here is 0.1 meters. If we wanted to find this side here at the bottom and we've been given an angle, let's have a look what we can get. So let's say, actually, I'm not going to give you guys any of these sides except from one. I'm just going to give you guys one side and I'm going to make you guys find the others. So 15 centimeters for the hypotenuse. Yeah, so we have h. I'm going to give you guys the angle of 40 degrees again, and now we're going to find y and x. If we now know that the angle is here at the bottom, then we can mark our opposite over here and the adjacent at the bottom. Now, what do we need to find out what y is? If we want to find y, O needs to be involved. So we need an O and we need h, because h is the value that we've been given. The triangle that has O and h is SO. Now, if we want to find out what y is, then we need to cover up the one that we need. So O in this case. Let's cover O, and what's left? S times h. So we're going to get sine, and again sine of the angle, 40 degrees, multiplied by the hypotenuse, which is 15. And we're done. No algebra needed. One-step answers. Yeah, so let's put this in the calculator. We have the sine, sine 40 multiplied by 15, and we get 9.6. Awesome. Now, how do we find x? Yeah, let's find x. Well, x is the adjacent, so we have an A. We can use O because we have obviously figured out what O is, but let's just stick with h. We have A and h, so that would be CAH, A and an h in the triangle. And again, which one are we looking for? We're looking for A, so we're going to take our triangle and we're going to cover A. And what's left is C times h. So we're going to get C, that stands for cosine, always of the angle, times by h, which is the hypotenuse. And again, we're going to go and grab the calculator. Cosine 40 times 15. There we go. And we get 11.5. Yeah, everything was one decimal place, right? In all of our questions so far. Okay, now these questions have all been the same. You guys were asked to find a specific side. Yeah. So this is one part of trigonometry where you can use an angle and another side to find another side. Now, there's one more thing that we can do with trigonometry, which is finding angles in a triangle, in a right angle triangle. So let's have a look at this example over here. If we have 3 over here and 5 here, and we want to know what this angle here is at the bottom, let's call this angle theta. You can also call it x or whatever, it doesn't matter. Remember, in mathematics, we like using Greek letters, yeah, to name our angles. In this case, I've chosen theta. You can call it whatever you like. So again, let's have a look. It's always the same. You have a right angle triangle. You write down what is the hypotenuse. You write down what is the opposite and what is the adjacent. And again, here we're looking at the angle theta. So when we want to find the opposite, it's the opposite of that angle that we're talking about. So nothing has changed. Yeah, we have an h, we have an a. This is the numbers that we've been given. So that would be CAH. Nothing really has changed. Sorry, that's a horrible triangle, guys. But doesn't matter. We're just going to write it down. This is what I would like you guys to do in an exam. Write it down quick and use it and done. So in order to now find what we need here, we cover up the angle. Well, if we wanted to cover the angle, there's nothing here that says angle. So you guys have to remember that if anything is about the angle, that is always the sine, cosine, or the tangent. Yeah, so that's this part over here. So what do we get? We get A divided by H. So we're going to get A divided by H, and that is the adjacent over the hypotenuse. But this is one thing that you guys still need to remember. If you guys are finding the angle, there's one step that you guys need to remember. Every time you're finding the angle, you need to use the opposite of the formula that was given here. So this one was cosine. Oh, let me just write COS. Yeah, it's easier. Cosine. Now, if you guys are finding an angle, you guys always need to remember to use the inverse function, the cosine to the -1 of that number, 3/5. You still use the triangle to find the number, but you just have to put it in the calculator using the inverse cosine. And that is always going to be your angle that you're looking for. So let's have a look how we can put this in the calculator. So we still have the cosine button over here, but now we're going to use the inverse, which means we have to press Shift cosine. And then you can see the little -1. You're welcome to go and make it a fraction to make it easier, which is 3/5, and press Enter. And now we get that our angle is 53.1 degrees. So it is still the same process. We still use the triangles the same way. We just need to remember, remember that if you're finding an angle, so if I say find angle, is sine inverse, cosine inverse, or tan inverse. Sorry, I'm kind of like moving over to the side, but that's okay. Okay, let's try this in the next example. And you guys can pause this one and try this one yourselves. Let's say we want to find this angle here, which I'm going to call alpha. And here we have 15 meters. And over here we have 7 meters. So what is the first thing we do? We mark our triangle H. Oops, that's really big. We mark H, the hypotenuse. And then we have this angle here that we are interested in. So according to this angle, this is the opposite and this is the adjacent. Now, what do we have? We have H and we have A. So that is going to be our CAH. See, we have CAH. That is our triangle. So now let's give this a go. We are again looking for the angle. So we're crossing out the C. If we're crossing out the C, then we know we're looking for the angle. So we have to use the cosine inverse instead. And this in the triangle still tells us what the cosine input is. So it's going to be A, which is 7, divided by H, 15. And this is going to give us our angle alpha. So let's go and have a look at our calculator. Again, we're going to go Shift cosine, and our angle is 7/15. Inverse cosine, there we go, 62. Alpha is 62.2 degrees. Okay, wonderful. If you guys were now asked to find the other angle, let's have a look here. Let's say we want to find beta. Then if you guys are switching the angle of interest, remember that you guys also have to switch the A and O. Now the hypotenuse, of course, always stays the same. But if we're now looking at the yellow angle, so let me take off the blue. We're now looking at the yellow angle. Now the 7 is the opposite. Oops, let me do it in red. The opposite. And the adjacent is unknown. So if we're now using this information here, we have been given H, we have been given O. So in our triangle is an O and an H. So that would be SOA. Again, the one that we're covering is the angle because we want to find the angle. So we're going to cover this part up, and maybe I'll kind of like make it a little bit more see-through. So if we want to now find our angle beta, then all we got to do is follow O divided by H, but put it into the sine inverse. So we still have sine because that was part of our triangle. Inverse, and then we follow O divided by H. So O would be 7 divided by 15. Note that these numbers here are the same, but it is using a different function because we're looking at a different angle. So this number now over here, again, we'll put it in our calculator. We're going to go back, shift sine inverse. Did that work? No. Shift sine to get sine inverse. And we're going to put in brackets 7/15 again, which is now 27.8 degrees. Wonderful. Okay, now I think we've done enough examples to finding the angles, but I'm just going to give you guys another example to do. We have 1 kilometer distance between 2 points. Over here we have 5 kilometers distance, and what we want to know is the angle, let's call this one X, and the angle Y. So this is the time for you guys to pause, try this question, write your answers in the comments, and I'll check them for you.